Okay, today we're reviewing Unit 13. This is an outline for the test. Should be a quick test. 18 little limits given a graph. Those should be very, very quick. 20 limits where you're given an equation. 10 you have to show me all your work. 10 are multiple choice. 6 multiple choice continuity questions, and a continuity proof where you show that the limit from the left is equal to the limit from the right is equal to the function value, or if they're not continuous, if it's not continuous, then you would show that one of these does not equal the other. And then a bonus. Alright, so I'm going to, in this video, I'm going to work through these problems in your review. So this first 18 problems got a little graph here. As x approaches -7 from the left, I would say that that is equal to infinity, which is a specific type of DNE. Okay. Limit as x approaches -7 from the right is also infinity. The overall limit there is DNE. If even one side is infinity, the entire limit, the overall limit, is DNE. F of -7 is not defined for us, so it literally does not exist. It was never defined for us. X approaches -6 from the left. -6 from the left is going to be -6 from the left is going to be a -4. -6 from the right is a -3. -6 overall. The limit from the left is not equal to the limit from the right, so this DNE. And f of -6 is 3. Okay, -4 from the left. -4 from the left is 1. -4 from the right. -4 from the right is 2. They do not match, so the overall limit is a DNE, does not exist. F of -4 is 2. You look for the solid dot. Okay, -1 from the left. -1 from the left is -1. -1 from the right is also -1. Since those match, the overall limit is -1. They have to match. F of -1. F of -1 is -2. Okay. Limit as x approaches 3. That's the overall limit. What is the overall limit as x approaches 3? Well, at 3 here, the limit from the left is -1, the limit from the right is -3, so those do not match, so the overall limit does not exist. Okay, f of 3. F of 3 is easy to find. You find the dot, that is at 4, so f of 3 is 4. Limit as x approaches -infinity. As x approaches -infinity, what is y getting closer and closer and closer to? Well, from the graph, it looks like that y is getting closer and closer and closer to -5. So I would say from the graph, that would be a -5. As x approaches positive infinity. As x approaches positive infinity, what is y getting closer and closer and closer to? Well, y is not only close to it, but equal to -3. So that would be a -3. Okay, some limits where you show me your work. Okay, as x approaches 5, the bottom is going to be 0. If I put 5 in the top, I get 25 minus 15 minus 10. That's also 0. The top is going to 0, the bottom is going to 0. So there's a hole that we need to get rid of. We can get rid of that by factoring. We rewrite limit. You have to rewrite limit. If not, you will lose points. Okay? I'm going to factor the top. I'm going to factor the bottom. You will not get far in calculus without being able to factor. Okay? So let's see, 5 and 2 minus 5 plus 2, that will get me that top one. Plus 5 minus 5 for the bottom one. The minus 5's reduce out, so we got rid of our hole. We got rid of our hole. We can reduce those because x is not equal to 5. It's only approaching 5, not equal to 5, so that's why we can reduce those. We can put 5 into the remaining x's, and I get 7/10. That is that limit. Okay, for this one, if I put -1 in for x, I'm going to get, let's see, 2 minus 3 is -1 plus 1 is 0 on top. If I put a -1 in here, I get 1 plus 5 is 6 minus 6 is 0. 0 over 0. So again, we have a hole. We get rid of that hole by factoring and reducing in this case. So 2x and x, 1 and 1, plus and plus, that will work for the top. On the bottom, x and x. Let's see, I'm going to need a 6 and a 1 here. Minus 6 plus 1, that if we multiply that back out, we get that. The x plus 1's reduced because x is not equal to -1, so we can reduce those out. We put -1 into the remaining x's, and we get -2 plus 1 is -1 over -7, so this is 1 over 7. That's that. My blue pen is about to go. Alrighty. Okay, 0. Well, I got 0 over 0. This time it's really easy to see that that's going to be a 0 over 0. So we have a hole. So we factor. So we're going to factor. Okay, I'm going to take out a 2x because that's in common. I'm left with x squared plus 1. Taking out a 3x, I'm left with 1 minus 4x. Yeah? The x's reduce out. The x's reduce out because, once again, x is not equal to x, so we can reduce those. I put 0 in for our remaining x's, and I have 2 times 1 divided by 3 times 1, so 2/3 is my answer there. Okay, x is going to -2. -2, well, the top is going to be 0. The bottom is going to be 0. Okay, so we factor. The top does not factor, it's just an x plus 2. The bottom does factor. That's a sum of cubes, so it factors into a binomial times a trinomial. We did this last semester. X squared will get us the x cubed there for our very first term. Okay. Back in the back, what will I multiply 2 by to get the 8? That will be a 4. Yeah. So square this, square that. In the middle, you take the product but the opposite sign. The product but the opposite sign. That's how that factors. The x plus 2's cancel because x is not equal to 2. That's leaving a 1 up on top. I put -2 into the remaining x's, and I get 4 plus 4 plus 4. That is 1/12. Okay, this limit. Tangent of pi over 3 is not a 0, so I'm not going to get a 0 over 0. There's no hole. Okay? Tangent of pi over 3 is square root of 3. Cosine of pi over 3 is 1/2. Okay? If I multiply top and bottom by 2, I will get 2 square root of 3 over 1 plus 8, which is 2 square root of 3 over 9. Okay? Number 33. If I put 0 in, the top is 7, so no hole. The bottom, though, is 0. What happens when the bottom is 0 but the top is not? The bottom is 0 but the top is not. What happens then? Well, that probably means you have a vertical asymptote. Either way, this is D and E. The bottom is 0, the top is not. Okay, that's page 1. I'm going to stop this video and start another one for page 2.